Have you ever wondered what lies beyond the three dimensions we live in? We're all familiar with the three dimensions that shape our reality: length, width, and height. They form the stage on which our lives play out. Think about your morning coffee cup. It's not just a flat image on your screen or a sketch on paper. It has depth. It occupies space. That's the third dimension for you. Or consider the room you're in right now. You can move forward and backward, that's length. You can go left and right, that's width. And you can jump up and down, that's height. Every object, every person, everything we know and experience exists in this three-dimensional world. It's how we understand and navigate our surroundings. It's the world as we know it. But there's more to our universe than just these three dimensions. Today, we dive into the mysterious fourth dimension. What if there's more to reality than what we can perceive with our senses? As we delve deeper into the fabric of the universe, we are confronted with the possibility of dimensions beyond the three that we are familiar with. We live in a world of length, width, and height, where everything from the tallest skyscraper to the smallest microbe can be measured in these three dimensions. But what if I told you there's more? Welcome to the mind-bending world of the fourth dimension. This isn't just the stuff of science fiction, but a very real field of study in the realm of physics. The fourth dimension, much like the three we are familiar with, is a theoretical concept of space which is hard to comprehend. We've been taught since childhood that there are only three dimensions, but the laws of physics suggest that there might be more. The fourth dimension is a spatial concept just like length, width, and height, but it's one that our minds struggle to visualize. Theoretical physicists suggest that the fourth dimension could be anything from time to a spatial dimension that we humans are not equipped to perceive. It's a bit like trying to explain color to a creature that only sees in black and white. But why should we even bother trying to understand the fourth dimension? Well, because it's there. Just because we can't see it or touch it doesn't mean it doesn't exist. Our understanding of the universe is limited by our perceptions, but that doesn't limit the universe itself. The study of the fourth dimension opens up new possibilities for understanding the universe. It could help us solve some of the greatest mysteries of physics, and perhaps even give us a better understanding of the nature of reality itself. Understanding the fourth dimension might be a challenge, but it's an exciting one. Let's unravel the mystery. Is the fourth dimension time, as some theories suggest, or is it a spatial dimension? This question has sparked countless debates among scientists and researchers. When we talk about dimensions, we often refer to the three spatial dimensions: length, width, and height. We can move freely within these dimensions and they make up the world as we know it. But what if we told you there's more? Some theories propose that the fourth dimension is in fact time. This idea, known as Minkowski space, was developed by a mathematician named Hermann Minkowski. He suggested that time is inseparable from space and should be considered the fourth dimension. This theory is the backbone of Einstein's theory of relativity, which explains how time can slow down or speed up depending on the speed of an object and the gravitational field it is in. On the other hand, there are theories that propose the fourth dimension as a spatial one. Imagine a world where, in addition to moving left or right, up or down, and forward or backward, you could also move in another spatial direction that we can't perceive in our three-dimensional world. This concept is often used in string theory, a theoretical framework where the point-like particles of particle physics are replaced by one-dimensional objects called strings. So, is the fourth dimension time or space? Well, it depends on who you ask. Some scientists lean towards time because of its profound implications in explaining the universe's phenomena, such as gravity and light. Others lean towards space, as it opens up a whole new world of possibilities in theoretical physics. There is no definitive answer, and the concept of the fourth dimension remains one of the most intriguing mysteries of our universe. It challenges our perception of reality and forces us to think beyond what we can see and touch. Whether time or space, the fourth dimension opens up a world of possibilities beyond our everyday experiences. How can we visualize something we can't perceive? This is the question that has baffled scientists and mathematicians for centuries when it comes to the fourth dimension. We live in a three-dimensional world, and we are equipped to perceive and understand things that exist within these three dimensions. However, when it comes to the fourth dimension, our perception falls short. But that doesn't mean we can't try to understand it. Scientists and mathematicians have found ways to visualize the fourth dimension using theoretical constructs and models. These models are like maps, guiding us through a territory that we can't see or touch. They use mathematical formulas and principles to create a representation of the fourth dimension that we can grasp. One of the most common methods used is the concept of a hypercube or a tesseract. Imagine a cube. Now imagine that cube moving in a new direction, one that's not up, down, left, right, forward, or backward. That's a tesseract, a shadow or projection of a four-dimensional object into our three-dimensional world. Another approach is to consider the fourth dimension as a series of snapshots of the three-dimensional world at different points in time. Each snapshot represents a single moment, and when you put them together, you get a four-dimensional movie of the world's history. Though these models and constructs are not perfect, they provide us with a way to wrap our minds around the concept of the fourth dimension. They help us break free from our three-dimensional constraints and venture into a realm that's beyond our immediate perception. The challenge of visualizing the fourth dimension is like trying to describe a color that doesn't exist in our spectrum. It's hard, maybe even impossible, but it's a challenge that can lead to great discoveries and deeper understanding of the universe we live in. Our inability to perceive the fourth dimension doesn't mean it doesn't exist. It's just beyond our perception. Why does the fourth dimension matter, you may ask? Well, the implications stretch far beyond mere intellectual curiosity. In the realm of physics, the fourth dimension has the potential to revolutionize our understanding of the universe. Currently, our laws of physics are bound by our three-dimensional perception. However, if we were able to perceive and interact with the fourth dimension, our existing laws would need a re-evaluation, a new perspective. This could lead to the discovery of new laws or the modification of existing ones. Imagine a world where we could manipulate the fourth dimension as easily as we do the third. The possibilities would be endless and almost magical. We could potentially bypass physical barriers, manipulate time, or even interact with parallel universes if they exist. In cosmology, the fourth dimension could provide the missing piece to the puzzle of the universe's creation. Some theories suggest that our universe may have originated from a four-dimensional star collapsing into a black hole. Understanding the fourth dimension could give us insight into these theories, bringing us a step closer to answering the age-old question of our universe's origins. Furthermore, the fourth dimension could aid in our understanding of dark matter and dark energy, two of the most elusive and mystifying aspects of our universe. Currently, we can only observe their effects indirectly. But if these phenomena exist in the fourth dimension, understanding this dimension could be the key to unlocking their mysteries. The fourth dimension also has implications in the field of information technology. It could revolutionize data storage and processing, allowing us to store and manipulate data in ways we can't even fathom yet. Why does the fourth dimension matter? Because it could change everything. It could redefine our understanding of the universe, rewrite our laws of physics, and revolutionize technology. It offers a world of infinite possibilities and mysteries to unravel. The fourth dimension may seem like a distant concept, but it's a mystery worth uncovering. Today, we've explored the fascinating concept of the fourth dimension. We've journeyed from the familiar three dimensions of our everyday world and ventured into the abstract realm of the fourth. We've grappled with the nature of this elusive dimension, exploring whether it's a dimension of space, time, or something entirely unfathomable. We've also attempted to visualize the fourth dimension, a challenging exercise that pushes our imagination to its limits. From hypercubes to tesseracts, our journey has taken us through some mind-bending landscapes, and let's not forget the potential implications of the fourth dimension. It's a concept that could redefine our understanding of reality, potentially unlocking new insights into the mysteries of quantum physics and cosmology. The journey into the fourth dimension is a journey into the unknown, a journey that might one day reveal the secrets of our universe. Until then, keep wondering, keep exploring,